So, shall we start now, Martin?
Yep.
Okay. So, good afternoon, good morning, wherever you are. Thank you for joining our session in the 2024 Stockholm World Water Week. This session with the title Improving Water Security in Africa, sorry, using next generation datasets will focus on one of the international water management initiatives for addressing the water data gaps in Africa through use of Earth observation. So in this session, we will share with you some of the approaches we are following, some of the data we have, some of the user engagement approaches we are following as well. Hope you will find very useful and then very engaging. My name is Abdul Karim Inside. I'm working for IMI as the head of the East Africa office located in Addis Ababa. My presentation will just give you an overview of the initiative, what we call the digital innovation for improving water secure Africa, a DWASA project. So I'll just give you about few slides with an overview, and then go ahead with the next set of presentations. So, data scarcity in Africa. There's a lot of challenges here. Maybe probably you can say Africa is one of the most water data scarce region in the world. Maybe I'm not exaggerating. So to address this data sets of the challenges we have in the data gaps, we can leverage new opportunities like, for example, the Earth observation, remote sensing on one side, but at the same time also increasingly most of this data is in the public domain. At the same time, we have now the computational resource we have in the cloud. Leveraging this, IMI has initiated what we call a digital innovation for water secure Africa initiative, which focuses, leveraging Earth observation to address the data gaps, water data gaps in Africa through complex applications, workflows for ready-to-use data streams using Earth observation data, digital innovation tools, and scalable approaches. At the same time, combined with user engagement, because we have the user side, building the user capacity, at the same time introducing the new technology to users, and then developing use cases so that the end users can make use of all these data products we are generating. These two approaches, on one side generating the data or co-generating together with the users, on the other side capacity building. With these two approaches, IMI has been working on this initiative for quite some time now. And today we will be very happy and pleased to share with you some of the data products we have. So I'll not go really into the details. One of the features of the products we have is we generate through this initiative water data at multiple scales. So from like landscape all the way to probably country, river basin, or country, even continental scale. So we have, what we call scale invariant water accounting framework, which we follow to generate water availability, and a number of other water availability related indicators. More details will be given in the second presentation. We also have like flood and drought related products. Unfortunately, we are not covering those today because of lack of time, but we also have, in this initiative, a big component on generating, data products for addressing flood and drought risks. Another important tool we are developing, we will have a full-fledged presentation and demo today, is a digital twin, creating the digital twin of a physical river basin. In this particular case, we are doing it for Limpopo Basin in Southern Africa. So you will have a presentation and then a demo to show not only the products, but the capacities of such a system for improving water management decisions in the African context. All what we are doing is, very much supported by what we call a very strong user engagement, because this is very important. At the end of the day, what we are producing, whether they are data or tools, need to be used by the users, and they have to be defined as well by the users. So we follow what we call co-generation approach in generating and co-developing the use cases, the kinds of applications end users want to make out of all this data, and build the capacity and provide quite diversified learning and awareness raising resources, and then also follow different capacity development models to enhance the capacities of end users. So we'll have today, I'm just giving you a highlight of the initiative. We'll have today presentations which cover most of what I have talked about in some detail. At the end of the session, we'll have about 10 minutes time for question and answer, for discussion. Please, in the meantime, put your questions, queries in the chat, which we'll check throughout the session. And then finally, we'll have time for discussion toward the end of the project, the end of the session. Thank you very much. This is my last slide. With this now, I call upon my colleague, Velpuri Naga, to start just showing us the kinds of water data products we have, which will be followed by other colleagues on different aspects of the initiative. Thank you very much.
Thanks, Abdul Karim. Can you hear me?
Yes, very well.
Okay. And my screen is visible?
Not yet, Naga.
Please let me know. I've shared my screen. Is it visible?
No, it has not come up to now. At least not for me.
Yeah, not yet.
Yeah, it's coming now.
Okay. Okay, good morning. Good afternoon, everyone. Thanks for tuning in. My name is Naga Velpuri. I'm a research group leader for Water Data Science for Action. It's a research group within IMI that focuses on converting data into actionable tools and products. So today, the topic of my presentation is going to be production of water data products using Earth observation and digital innovation technologies, where I'm going to touch on some of the products that we are producing within the DIWASA, Digital Innovation for Water Secure Africa project. On the screen, you will see a flavor of the summary of the few data products that we are producing. The first one is the river flows. We are actually producing high resolution products of river discharge products for Africa. And I will show you a few slides to give you a flavor of how the product is going to look like. And the second one is we are producing a lot of data on agriculture water use. So one of the key focus of this project is to produce a lot of data on agriculture water use, rain-fed systems, irrigation systems all across Africa. And we have few products that, to share with you. And the third one, the most important one, is the water accounts. We are producing a lot of water accounts, especially in Africa. The baseline information on water availability, water resources availability, and the scarcity are usually not available easily. So we are using Earth observation data to produce a lot of information and indicators, generate indicators and dashboards that are based on water accounting framework. We're going to touch on this as well. And as Abdul Karim pointed out, we also have products on water risks, which cover flood and drought, and also a desalination product for the entire Africa is also available. So for the interest of time, today I'm going to focus on the first three data products: river flows, agriculture water use, and water accounts. So to start with the river basin discharge, so IMI has produced entire Africa-wide river basin discharge. It is produced based on USGS hydrological model, and then we routed the discharge based on a model called MISO route, which is produced by NCAR from the USA. So this river discharge is a very high density product available right now. Version 1 of it is available right now with us, which covers around 64,000 stream segments. So the animation on the right side shows you a monthly discharge data for the continental Africa. And then you would see that the density of these stream networks cover all of Africa, and it's pretty dense. And on the bottom, you see an animation of the monthly discharge for the entire Africa. And then the red dot, which is transitioning, indicates the time period of the animation. So this data product is available, and then we are also producing now the version 2 of it. The version 1 is under review in Nature Data Journal, and then version 2 will also be available. The advancement in version 2 is basically that we are going to increase the density of these stream networks covering the entire Africa. So from 64,000 stream segments, we're going to go to around 650 1,000 stream segments. So it's like going to be a tenfold increase in the data product. Using that data, we are also not just producing the data, we are also creating a lot of indicators using the discharge data. One such indicator is water dependency ratio. So what do I mean by that? So using the stream discharge data, we are now able to identify the streams that are actually bringing water into a country and taking water out of the country. So basically, you can monitor how much of water is flowing into a country, how much of water is actually generated within the country boundaries, and how much is actually leaving. So using the inflows and outflows on the left side is Ethiopia, and then you see that Ethiopia, only 1.2 kilometer cube of water is actually entering from outside the country boundary, and most of the water, 130 kilometer cube of water, is generated within the country. So using these two parameters, inflows and outflows, we are actually able to derive water dependency ratios, which means that you can understand how much of this country, a country, is actually dependent on the water that is coming outside the country. So for Ethiopia, the water dependency ratio is 99% is it generated internally, so it only depends around less than 1% water that comes from outside. But in contrast, on the right side, you will see that for Ghana, around 52% is actually generated internally, but 48% of the water actually comes from outside. So the water dependency for countries like Ghana is a little bit more um, when compared to the Ethiopia in here in this case. So we are trying to generate these kind of information for each and every country so that we can generate that for use that for management of water resources. The other product that we are generating is for transport river basins. We are trying to understand how much of each country contribute or depend on other member states, which means that how much of Ghana on the right side, you see the receiving country in here, and how much of Ghana the water comes from which country. So 30, 40, 45% of Ghana resources actually emanate from Burkina Faso, and then 32% come from Togo, and 23% come from Benin. So this kind of information can be extracted from that discharge product. The second product that we are generating is basically agriculture water use data. Here I have a map that shows the locations of irrigation and rain-fed areas. So using that product, we are able to now quantify how much of water use happens in rain-fed, how much of it is actually informal or supplemental, how much of it is actually formal irrigation. And not only that, we are also able to quantify the deficits in the rain-fed water systems, how much of the crop water use is not being met. And also in the irrigation systems, we are also accounting for deficits as well as efficiencies. So in places where we are using more than required, in places we don't have enough. So all of these things are being produced for each country. The statistics are available at a national scale and also at the regional scale using the spatially explicit data that is being produced within this project. The third is the most important one is the water accounting framework that we use. So the water account IMI has a water accounting framework that produces water accounts. So when I say water accounts, it's basically accounting for how much of water is coming in, how much is leaving out, and what happens to the water within the basin. So everything is accounted in here. It's a very comprehensive accounting framework of looking at the hydrology and the water resources. It uses remote sensing data sets, so there's minimal in situ data required, which is a major issue, a challenge for implementing hydrologic modeling in Africa. So we are using Earth observation data to overcome the data scarcity issues. And this model is also an open source model, which means the codes are available. Any of you are interested, please reach out to me. We are happy to share the codes. And then we produce a lot of information in terms of dashboards that I'm going to share in a minute. And then the idea is to produce a lot of water scarcity indicators, water availability indicators, so that it can improve decision making and water management. And as Abdul Karim pointed out, we are producing this information at multiple scales. And these are some of the results that we already got. On the left side, you see continental water accounts. So at a continental scale, we are able to understand now how much water comes in, how much goes out, and how much is actually consumed as an ET, how much is leaving into the ocean. And we can also derive a lot of parameters and summarize the water use in here, and also the parameters, so the quantities of water that is available for further use after meeting the existing demands, and how much of it is available from surface water, how much is available from the groundwater. And this groundwater estimates actually is within the allowable rechargeable limit. That means we are not actually quantifying the entire groundwater potential, but just the potential that we can extract within the safe limits of recharge. On the right side, you see the regional water accounts. The same thing done at the regional scale. And these are some of the examples of the basin water accounts. On the right side, you see a kind of a dashboard or a sheet which summarizes several, about 30 different indicators, and that you can use to understand water resources. We are also generating water accounts at a national scale. So we have already completed around 16 countries, and we are progressing on time with a plan to finish before the end of the year for all the countries. So for all 54 countries in Africa, we're going to generate national water accounts, so that this information is available at the click of a button. And we are arranging and distributing these products. So it is being shared by geoportals, AWS ODR, which is Open Data Registries. The data is also available on the Digital Earth Africa and other platforms. And this is one website. The QR code is on the right side. This is one website where you can actually have a flavor of these data sets. You can look at it, read about them, and then access the data. So please do visit this site. And in summary, we are using Earth observation data to fill the data gaps and also generate a lot of key data products for Africa. Really thank you for tuning in. Yeah, that's the end of my slide. Thank you.
Thank you, Naka. Thank you very much. Quite a lot of course information within a very short time. Thank you. So the participants, look, this DIWASA initiative is part of a bigger framework, an Africa-wide framework. We call it Digital Earth Africa. Some of you may be aware of Digital Earth Africa. So we are really part of such that bigger framework. And now the next presentation by one of my colleagues, Mulugeta, will be how we are connecting with Digital Earth Africa with an Africa-wide initiative for making a large set of, Earth observation data sets. We call it analysis-ready data sets for users in Africa and beyond. So ours is DIWASA is focusing on water, whereas Digital Earth Africa is focusing a lot more, also partly also to some extent also water data. Now, Brigetta will present to you the work in progress in connecting to the Digital Earth Africa and then making this data, what we are generating, available widely through the Digital Earth Africa platform. Brigetta, you have the floor. Thank you.
Mulugeta, you're muted.
Okay, can you see my screen?
Yes, we can see.
Okay, thank you very much. Good morning, good afternoon, everyone, wherever you are. I'm Mulugeta Tadesse, special data scientist based at IMI East Africa. I will be talking on converting water data products into decision support tools, illustrating from the DIWASA integration with Digital Earth Africa. So as already Naga discussed, we have a lot of data products from water accounting, from DIWASA water accounting and indicators also. These are some of the data sets we have, which we are going to put on Amazon Web Service Open Data Registry, which can be accessible to users publicly through different platforms. Also, through Digital Earth Africa, directly can be accessible to the users. So the DIWASA and Digital Earth Africa data integration is basically has an objective of utilizing Digital Earth Africa platform to access and retrieve data set produced by DIWASA and develop visualization and analytical tool based on Python Jupyter notebooks. As already Naga mentioned, our water accounting framework produces dataset at different geographic area of interest, and the tool we are also foreseeing is based on different geographic areas, continental, national, subnational, basin, catchment, or at different geographic area level. So our data are distributed across different platforms. I also already mentioned here. I'm mainly focusing on Amazon Web Service, Open Data Registry, and Digital Earth Africa. The Digital Earth Africa is providing data through Open Data Cubes, the ODC, and our data from DWASA will be accessible through the Open Data Registry. The Digital Earth Africa provided sandbox where we create analytical tools. So just briefly, for those of you who do not have information about Digital Earth Africa, it is a program for the entire continent, which provides free and open access analysis-ready Earth observation data and analysis tools for Africa. The data sets which are organized by the Digital Earth Africa is accessible through Open Data Cube, and Digital Earth Africa provides also a sandbox where cloud-based computational platforms are accessible through Jupyter Lab. It is providing a cloud-based analytical platform. So the DWASA data, we have about 4 types of modalities, how we can access the data, carry out analysis based on the data sets. We have 2 kinds of storage. The first one is Amazon Web Service from DWASA. It is S3 bucket. And the other one is the Digital Earth Africa S3 bucket, which is on Amazon Web Service. And the Digital Earth Africa is accessible through the data cube, as I already mentioned, and our data sets are accessed through the ODR, Open Data Registry. So the first modality is just a standalone modality where we can directly access the data on S3 bucket, which is which could be accessible only by the internal users, and also the S3 bucket, which is on the public folders, can be accessible to users, so that we use Jupyter Notebook, which is a platform hosted on Amazon Elastic Compute Cloud services, which generates, maps and visualizations and data-driven analytics. This can be integrated into external data sources to further do the analysis and provide analytical information and map visualization and in different formats. The other modality is using a Digital Earth Africa platform. From the Digital Earth Africa platform, we can integrate data from public S3 bucket on our DWASA web services, and also from Digital Earth Africa through Open Data Cube. And also we can integrate into external data sources from different web services, APIs like that. And the other option is using our Open Data Registry, which provides also as a stand alone, analytical tool without using Digital Earth Africa platform. We integrate external data sources from our ODRs and creating analytical tools. The other modality is using Digital Earth Africa, which directly access data from the ODR and from the open other data sources, and also from the ODC, and creating in the analytical tools, which provides maps and visualizations. So in general, our focus is where Digital Earth Africa and our data are integrated into this kind of modalities. So these are some of the few example notebook topics for integration, which we are going to develop. For today, I will be demonstrating on using a rainfall statistics across multiple scales on using the ODC, which is Digital Earth Africa Open Data Cube, and also providing evapotranspiration statistics across multiple landscapes, which takes data from our S3 public S3 bucket and providing integration into the Digital Earth Africa and developed on Digital Earth Africa sandbox. So I'm just going to provide you a demonstration. Just a moment. So this is a kind of tool that we are developing. This is a Digital Earth Africa sandbox environment. So where we develop our tools, this is a Jupyter lab environment on Digital Earth Africa. We have developed a summary of rainfall statistics across multiple scales and also using evapotranspiration data, where the users provide their own geographic area of interest. Here I'm using the Ethiopian situation where in the Awash river basin, providing the boundaries, subcatchments, and at some point localities where I am interested to do some analysis on rainfall data. And then the first thing is that we connect to the data cube, Digital Earth Africa data cube. And then once the Digital Earth Africa data cube is connected into, our frame, the platform, then we can access the data directly. This is our area of interest. We have subcatchments. We are generating data, long-term mean monthly rainfall data for these catchments. So these are the data set. We have monthly and daily rainfall data. I'm using monthly data rainfall and just accessing the data through the ODC. And I have here, I'm using about 500 monthly data. Want to aggregate them into long-term climatology, rainfall climatology. And here I'm going to present you. This is a long-term mean monthly rainfall across the basin. And this is the kind of analytical things that can be done. Here I have some localities where I want to just compare rainfall, monthly rainfall for different localities within a basin. So I have a graph which showing different locations. Like if you see, we have Addis city, we have Desi city, which is in the highland areas. And also we have the lowland areas where rainfall is very scarce. And then we are also generating rainfall statistics for each sub-basin using zonal statistics and generating data, monthly long-term data, monthly long-term data for each of these catchments, and then linking this data into the shapefile, and finally presenting the results. This is just the static rainfall data for different catchments. And this is where an interactive data, rainfall data for the catchment. So here I'm going to also show you the ET data, which is computed for different land use, land cover data set. Similar to the rainfall, we have to provide the area of interest. Still, I'm using the Awash Basin, and then connect the WASA data from S3 public S3 bucket. Here is where I have a link to directly accessing the data on our S3 bucket, which is outside of the Digital Earth Africa, combining both Digital Earth Africa data and our data for integration. This is my area of interest. And here is our loading land use land cover data. I'm using 2021 land use land cover data from European Space Agency land cover, which is a 10-meter resolution, and trying to compute, different water consumptions on different landscape. So we have got about 8 classes within the Awash Basin, and here is the land use land cover map presenting in the basin. Then once I have an access of land use land cover data from the Digital Earth Africa through the data cube, I'm loading the actuality from IMI S3 bucket. And then finally presenting the monthly values, and then computing statistics for the consumption at each landscape. And here are the final output. Here are the different land use land cover water consumption levels in the Awash Basin. This is my final point. This work is in progress. Thank you very much for your attention. I'm done.
Thank you, Mulugeta. I know it's very challenging to give a demo within a very short time. Thank you for keeping time. Thank you very much. So now I give the floor to Chris and Hugo. So they are going to demonstrate to us the digital twin. I mean, it will be very exciting to watch the demo. First, maybe they will just tell us about what this is about, and then have about 5 minutes or so demo. And hopefully this will be like an avenue for like getting like kind of a teaser, so that you'll also continue communicating with the team and get to know a lot more about this. Thank you. Chris, you have the floor, or Hugo, whoever is presenting.
Thank you, and greetings, everybody. So just to introduce myself, I'm Chris Dickens. I'm from IMI, and I'm joined today by Angie Garcia, who's also from IMI, and she brings the AI and data processing brains to the project. And then also Hugo Retief, who's from an NGO called Award, based in South Africa, and you'll see the role that he's playing in a minute. So the whole concept of the digital twin it's a very, very novel project, and this is really the first time it's been applied anywhere in the world at the kind of scale and the intensity that I think you'll see demonstrated today. You can see there's quite a large team involved already, and things are going very well. Slide, please, Hugo. So really, what is a digital twin? You know, the old concept of water resource management relied on static data sets, which very often became outdated. And they required water resource managers to have a lot of understanding of how all these data sets fit together, and they have to generate reports and take management actions based on all of that. What we're doing now is we're trying to develop a completely new system of management where we have a digital twin where it integrates data near real time in a 3D user-friendly kind of format where it is much more accessible and much more relatable by users. And the users don't have to know all of the ins and outs of the underlying models to be able to interpret and to run scenarios, et cetera, That picture that's spooling in the background is just one example of a very, very high resolution LiDAR scan at a centimeter resolution, where you can actually build on that to develop all sorts of water-related issues. But we were not going to into that now. So basically, this just illustrates that we're making use of FAIR principles, that the data is open source, it's fully accessible, it's interoperable, and the data is reusable and is very easy updated. You can see on the right-hand side there, we have a number of data sets where we're pulling data from these data sets via multiple APIs and feeding those into the digital twin, and also into a chatbot, which we're going to demonstrate just now. And the data is all stored on the cloud and the data cube and so on, which you've just heard about in the previous presentations. So the real foundation of the digital twin is the SWOT plus model. And so we've developed a SWOT model for the whole basin. You can see it's based on there's statistics related to the data, the rainfall, the discharge, the water bodies, the environmental flows or E-flows, and the number of SWOT model channels and so on, which are included in the model. And so essentially this runs near real time, is updated near real time, where we take the rainfall data from CHIRPS data to update the model. And so at a near real time basis, you can actually assess for all of those multiple channels in the whole basin, the present day water flows, discharges in those river channels. Slide, please. And this is probably the most fundamental of the outputs from it. And so you can click on any one of those channels, and eventually, at the moment, not all of them work to the same level of detail, but basically you can click on any one of those channels, and the green line there is showing the natural water flow over time, and you can see the date scale at the bottom. The dark line is the present day flow as analyzed by the SWOT model. The dotted line is the environmental flows. So by definition, the environmental flows is that amount of water which you're not supposed to touch. You're not supposed to make use of it because it's there to actually protect the environment, and not only for the benefits of the environment, but for the users of that environment as well. So the blue shaded area then becomes the amount of water that's available. In other words, it's any water greater than the environmental flows up to whatever is present in the water in the river today. So the blue area is the available water. You can see on the left there and right on the right-hand side, there's a small area of red, and that's where the present day flows have now dipped below the E-flows. So you're actually now eating into the E-flows, and you basically taking water from the environment. And what we've developed is that the minute that happens, it sends out automatic alerts to managers so that they are immediately alerted that there's a problem. You can see also towards the right-hand side, you've got a vertical dotted line with historical on the right, left, and forecast on the right. So it's doing this for historical information, but it's forecasting the future up to 3 months ahead as well. And you can see the different probabilities of the outcomes going forward with the forecast. Slide, and you take over, Hugo.
Sorry, I was muted there. I should have kept it unmuted. So this is just an example of the digital twin where you can actually interact with the various data sets that have been collected, that are being served by the APIs as well as the data cube. So it's very user-friendly and is jam-packed with different features, allows you to put together your products that you're wanting to view. It allows you to go in depth with the descriptions that are available for the different layers. It also allows you to control the base layers and also export and share with multiple users. So it's just to show you that it has a spatial interface, but then there are also various other components to it as well. So I'm just going to quickly play here. So for example, we can view the water body levels and chart them. You can see the E-flow alert levels that Chris was referring to that, can go out to the users. You can see the SWOT incremental contributions changing over time. So there's a lot of data sets that come into play that can be used together and be shared. I think that's it, Chris. Over to you.
Yep. So, just in case one is still a bit overwhelmed by all that complexity of running a model, what we're now developing is really quite unique, and that's a chatbot. And so the whole idea is that a manager or a user, a member of the public, could actually interrogate all of that fancy data provided by all of those models using a chatbot. And I think all of you have experienced using ChatGPT. So we're working together with Microsoft and OpenAI to develop a chatbot, and it's already quite extraordinary. But bear in mind, though, that this is still a prototype. It's based on quite limited data at the moment, but you'll see now that it's already very, very powerful. Unfortunately, what we're going to do is we're going to run a video of a demonstration. So it's a little bit staged because it's a video. But then what we're going to do is paste a link in the chat. And immediately after this session, we will go over to if you want to follow, click on that link and we'll join a different open discussion where we can actually demonstrate the chatbot live. So Hugo, over to you with the chatbot.
Thanks, Chris. Yeah, so given that it is a video, I'm going to try and keep with the timing as much as I can, but it's just a short clip. So essentially, when a user lands on the chatbot, there are a number of buttons which are just guiding in terms of initializing a chat and will provide you with a question. In this case, we asked it, please analyze the alerts for the previous month, which was July. It provides a summary of the data itself for each one of the eFlow sites, and also provides a user-friendly map indicating the sites that have various alert levels. We can then ask it to chart the eFlow for the worst site. So in this case, the Leboeuf River is the worst site. It will identify all the data available through the APIs and the resources that it has on hand to be able to then produce the chart. You can also access all the information that was used to produce the chart. So it has all the references and resources available that you can use. We can then ask it to look for rainfall sites near the eFlow site. So it uses an API that can draw the geolocations for the different rainfall sites. As we know, rainfall drives the hydrology, so we're wanting to see what's happening. It returns a map of all the rainfall sites around the eFlow site, provides it in a table, as well as then as a map. We can then ask it to chart the rainfall for a specific site that's near the eFlow site. So in this case, we've asked it from 2023, the beginning of the hydrological year, but all the way through to the end of December, so that it includes the forecast. So we have both the historical and the forecast data, which is very important in identifying the trajectory. Are things going to be getting worse or better? You can also ask a complex questions like, can you please write a summary report on the water availability, e-flows, and alert levels for July 2024, include the drivers, mitigation strategies, and insights drawn from the LIMCOM documents. Additionally, provide maps highlighting the worst and the best months, as well as e-flow charts for the best and the worst sites for the period of October through to December 2024. Also, please include the rainfall chart that we identified in the previous question. So it keeps track of everything. It has now produced a quite detailed summary report of that rather lengthy question. And in it, it includes the key insights that we asked for. So you'll see it bulleted all the various aspects that it believes are key insights with regards to the eFlow status. It's also provided some mitigation strategies that could possibly be implemented, the charts that we've requested, including the rainfall chart, and then alert maps for the worst and the best sites. Unfortunately, we saw no references were included. And if we are going to be producing a report, we would like references. So we can ask it to include all the references that were used in producing the summary report. It will then go and rework itself into a new format that then obviously includes the in-text referencing. So these can be seen as hyperlinks, but you can also choose to say, I want it in Harvard style or any style that you would like, and it will be able to recreate it. And that's a very quick elevator demo of the chatbot.
Okay, thank you very much.
Thank you.
Hugo.
Just one more slide. One more slide. Just to emphasize that chatbot is really responding to questions. It looked a bit staged in the video, but it's really responding to in detail to questions. So just in final word is that this digital twin is only really going to work if it's developed together with stakeholders. And so we're working very, very closely with the Limpopo River Basin Commission, LIMCOM, and they are really keen. They're participating very, very closely. And it's wonderful to work together with a large stakeholder organization like this. So thank you very much, Abdul Karim. So remember, if you want to join a live demo of the chatbot, you'll see it in the chat.
Okay, Chris, I can see some reaction already on the chat. So you have succeeded very well. So now, sorry for the time. Alam again now, please go ahead with the user engagement side, because all these are technology, data products, and so on, but this doesn't really make sense if the users are not there. So we need to have the users really coming on board, co-generating, and then using the products we have. So Alam Saget is in charge of the user engagement. You have actually less than 10 minutes because we are running out of time. Alamsaka, you have the floor. I can see your screen. Just make it on projection mode. Alamsaka, can you hear me? Alamsaka, can you hear me? Really sorry. Alamsaka, if you maybe you are muted, can you check if you are muted? Oh, okay. You are with Murugeta. Sorry. Okay.
Yes. Yeah.
There's some technical issue with Alamsaka's presentation. Can I run it from here, Alamsaka? I have your presentation. Sorry. Yeah, now you can start. We can hear you.
Okay, thank you. Sorry for the technical difficulty. My name is Alam Sagat.
Yeah. Start from the first slide. Now you are in which slide? Fourth slide or sixth slide now?
Okay.
Yeah. Okay.
Let me share it again.
Okay. Now it's coming. Yes. Can you make it presentation mode?
Is it on presentation mode?
Not yet.
It's on presentation mode on my screen.
Maybe it's coming.
Okay. So shall I start speaking?
I think it can start. Go ahead.
Okay. Thank you, Abdul Karim. My name is Alam Sagat. I am a researcher at the International Water Management Institute.
We can hear you, Alamsaka. No problem.
Okay, great. So the topic of my presentation is user engagement and capacity development. So I will try to make it within less than 10 minutes. The user engagement and capacity development in DIWASA focuses on 5 areas. The first one is to meaningfully engage stakeholders in our project, including co-development of applications, or we call them use cases. We also aim at building the capacity of stakeholders or end users. We also prepare learning materials for in-person training as well as self-paced or online training. And we try to increase the number of end users of DIWASA data products by providing support to young professionals. And we also provide support to the community of practice. So our approach Our approach involves consultation. First, we talk to stakeholders. We have face-to-face and online meetings, series of meetings, and then we have also consultation workshops with them. The other is a co-development process, which involves co-identifying use cases of their interest, just to demonstrate how DIWASA tools and products can be used to address real-world problems that stakeholders are facing. And then we have a co-design workshop, prototype testing, and also we have a dissemination of results with stakeholders. DIWASA also has a series of trainings because it requires the products, using the products requires a special set of skills. For that reason, we have series of trainings. Those trainings can be in person, self-paced. Also, we have webinars. And the other approach is coaching and mentoring young professionals, especially our internship program, MS Thesis Awards, that they provide opportunities for young professionals. And also we have these monthly webinars for stakeholders to exchange ideas and experiences on the use of our DIWASA products. The stakeholders come from various scales because of the nature of DIWASA products. It is a multi-scale product. So for that reason, we have stakeholders from sub-basin, national, basin, and continental levels. So at national level, we have the water sector, the environment, agriculture, irrigation, weather service, and disaster risk management. In addition, academia and research organizations are key stakeholders of DIWASA. What you see here is some of our stakeholders from Ethiopia, Ghana, and also including the basin development organizations in Volta, Zambezi, and Nile Basin. So in our stakeholder consultation workshop, especially the kickoff workshop, we have three objectives. The first objective is to reach a collective understanding with stakeholders about what DIWASA can offer and cannot offer. Yeah? We talk about our products and tools and also discuss with stakeholders. The other is to provide hands-on exercise so that our stakeholders can have an understanding of our tools and products. And finally, the DIWASA team and the stakeholders co-identify potential use cases that can be developed together to address water security challenges that the stakeholders are facing. So these pictures are taken from recent consultation workshops in Ghana on the right, and also in Ethiopia on the left. The Ghana workshop covered about 6 countries of the Volta Basin. So in the use case co-identification, we follow some steps. The first one is stakeholders come up with a long list of use cases, and then they evaluate those use cases against 3 core criteria: the feasibility, relevance, and impact will be evaluated, and then they come up with a short list of the stakeholders. Then our team, the DIWASA team, evaluates those short lists against feasibility, data availability, and also if there is redundancy, we will merge them and we come up with the final set of use cases for each priority country. By priority country, we mean Ethiopia, Ghana, Burkina, Zambia, plus some other additional countries. So immediately after the co-design workshop, there is, of course, some weeks between them. We have these co-design workshops with stakeholders. So in this workshop, what we do is we further elaborate the problem, we better describe it, and also we agree with stakeholders about the scope of the use case. In addition, the use cases, most of them may require ground-based data. So we use mostly Earth observation. So we have to identify the data requirements and also share responsibilities to get those data with the stakeholders. We also, in the co-design workshop, we also agree on the work plan because we have a co-development process. We agree with stakeholders about the work plan. So the picture you see here is from a recent co-design workshop with Ministry of Irrigation and Lowlands in Ethiopia. So we will have similar project co-design workshops in other countries. In DIWASA, we have series of trainings for the coming 3 years. The first training, for instance, the one we are conducting this year, focuses on enabling stakeholders or end users to be able to better access and use as Earth observation data. So we are collaborating with Digital Earth Africa, as Mulgeta presented it. So with the Digital Earth Africa, we are conducting this workshop. So the first thing is the stakeholders will be able to use the Digital Earth Africa sandbox to access and use data using Python notebooks. And in the meantime, the trainees also learn about Python programming skills because it's important. And finally, they are given projects so that they use the Digital Earth Africa data to develop small case studies. So this is a result of survey from the recent training. The red one shows percent of respondents prior to the training. So 1 means they have low confidence in using Digital Earth Africa sandbox. 5 means they have high confidence or they consider themselves as experts. So you can see that we have increased the confidence and experience of stakeholders to use Digital Earth Africa sandbox. Thank you very much. This is a brief presentation from the stakeholder engagement perspective of DIWASA. Over to you, Dr. Abkan.
Yeah, thank you very much. Look, I understand this is really a lot of material within a very short time. Yes, participants, initially the idea was to have a 1.5 hour session, but it has to be like compressed into 1 hour session. I hope you've got the gist of what we are doing, what we are trying to communicate to you. So you're most welcome to contact us for more information. And I have seen in the chat box a lot of questions, actually a lot of interaction. The chat box has been very, very active. We have actually 4 minutes now. Maybe I can give 2 chances, just 1 question each, really half a minute each for 1 question, and then addressing any specific speaker. Unfortunately, we would love to have more time, but unfortunately the session will close at exactly 1 hour mark. So just raise your hand, then the first to first come, first served. Each 1 question, half a minute, please. I don't, yes, I can see Mamela. Yes, please go ahead.
Yes, thank you. Can I go ahead?
Please go ahead. Please go ahead.
Yes. My question is for Chris and the team regarding the project down in Limpopo on digital twins. And I've posted a question in the chat box just to get a bit more info on the stakeholders involved, because I think it's very interesting, particularly for the DWS. It's an government department that I represent, and just wanted to know if they're involved and if probably there's room, and because I see quite I think it's quite interesting, and yeah, a lot of the data sets could come from our data sets. Thank you.
Yeah. No, thanks. Very good question. So yes, so as I mentioned, we're consulting a lot with LIMCOM, who are the Limpopo Basin Commission, and the South African government sits on as one of the commissioners on LIMCOM, so they are intimately involved. And we have had meetings with a broader group of LIMCOM, including the South African delegation. But you know what it's like in a large government department, it takes time to roll out into the government. So if you can encourage it from your side, that would be brilliant. And yes, we really need to get access to your data. We have a lot of it already, but the more we can get, the more goes onto the digital twin, which becomes open, free to everybody. So yeah, we really need to have a meeting quite soon with the South African government to finalize that kind of data access. Thank you.
So we've just left with 1 minute, so I think we cannot entertain any other question, unfortunately. But thank you very much. I think from the questions I see in the chat, a lot of interest, very, very valid and intelligent question, really. So please reach out to us with questions you may have. We have put our email addresses there. Thank you so much. Thank you, really, everybody. And then have a nice afternoon or evening or morning, wherever you are. Thank you very much. Bye-bye from my side.